In this video, we'll take a close look at all the steps I took to recreate the Magnesis Rune from the Legend of Zelda Breath of the Wild. What Magnesis does is to let you control metallic objects by moving, pulling and pushing them. If you want to see more videos in the future like, consider subscribing to stay up to date with everything. For this video, the project files will be public on Github and you can get them from the description below. And now, without further ado, let's jump straight into the video. Right, so here we are in an empty third-person template project. The first thing that I'll do is to create a material which is going to highlight all the metallic objects. So I'm going to call this metallic underline matte. Let's get in here, and the first thing that we'll do is to set out the base color. Because I don't have a custom object or a texture or whatever, I'm going to have a color. So to get that, let's press 3 and left click while pressing it. So this is going to get us a constant tree vector. The color is going to be white, and as I said, you can also use a texture or whatever. Now, one last pin that we have to set up is the emissive color. For this, let's get another constant tree vector by doing the same shortcut, and this one is going to be black. We are going to multiply this with a base color, and we are going to get another multiply node. In this one in A, we are going to have the first multiply node, and in B, we are going to have a constant 1 vector. To get one of those, press 1, left click while pressing 1, and then the default value is going to be 15. Okay, plug this in the emissive pin, and now you're going to see that nothing happens. And it is because this node is black. If this would be, let's say, the default color for metallic objects which are not selected, this is how it will look. Right, so what this means is that we will need to make this a parameter, because we are going to change the value of this color through blueprints, because there is a node called set vector parameter value, right? So let's convert this to a parameter. I'm going to call this emissive. Okay, let's save and make sure it's back to black, right? So there's no emission at all by default. Close it down and we are done with it for now. Let's create a new blueprint, and this one is going to act as the master blueprint for all the metallic objects. Let's get an actor, and this one is going to be, as I said, metallic underline object underline master. And now let's enter the blueprint. In here we are going to add a new component, and this one is going to be a static mesh, which is going to represent the object. Don't set anything in here other than collision preset custom, because maybe sometimes when you create a blueprint, a child blueprint of this master, you will want to change the collision. Let's compile. Now let's go to event graph. Here let's get begin play. Alright. And now what we'll need to do is to create a material instance from our static mesh, so we can change values individually for each mesh. You're going to see later exactly what this does. So let's first create it. From static mesh, create dynamic material instance. Alright, with the source material, the material that our static mesh has. So get material, plug this in source material, and from the return value, promote this to a variable. I'm going to call it material instance. Okay. Now let's compile. Now let's create our first child blueprint. Right click on the blueprint, at the top create child blueprint class. And I'm going to call this platform underline metallic, because this can be used as a platform to get between two islands or whatever there is. The static mesh is going to be a cube, the material is going to be the one that we just created. Alright, we are going to enable physics, that is really important, otherwise this is not gonna work. Right, so any metallic object has to have its simulate physics enabled. Now let's rescale this, so it's a little bit bigger, compile, and now let me go into third person character real quick, because here I already set a little bit of blueprint. You don't need to set it, right? This is just so I can show you something real quick. Let's put two platforms in our scene, and now let me show you what the create material dynamic material instance does. Now I'm going to run my custom blueprint. You can see this turning into the purple color that we just had before, right? And we are turning this one into the purple emissive color without turning this one as well, right? So this is rather interesting. Now let me also show you the blueprint so you understand what happens. Basically, when I press X, I do a line trace, and if I hit a metallic object, I'm going to set from the material instance a parameter with the name emissive, the same parameter we set in here with emissive. I set the value of this pink color, right? So now let's delete this because we really don't need it. Okay, and now let's see how we set up the blueprint in our character. Okay, let's go in the viewport and let's create, attached to the mesh, a sphere collision component. And let's set the radius. We want this to be rather big, so I'm going to set it to 3000. This is because we'll use this to detect all the metallic objects inside this radius. And let's make sure that our collision preset overlaps with everything. And then let's also go to the metallic object master and make sure that the static mesh generates overlap events. And you can see it does. Okay, let's get on component begin overlap and on component end overlap. And now what I want to do is to store all the metallic objects that enter and exit the component, the sphere component. So I'll do that by creating a variable, and it's going to be metallic underline objects, and this is going to be an array with the type metallic object. So first we're going to cast to metallic object master from the other actor, and if this is going to succeed, or so it's not a fail, we are going to add to the array the as metallic object master. And now remember, the fact that this is the master and not a child is not going to affect anything. Even it's very good because child blueprints from the master are treated even as metallic object masters, right? So basically even the platform metallic blueprint is going to activate this cast. Okay, now let's copy the entire thing, other actor in the object, but instead of adding on and overlap, we are going to remove item, plug this in here, and that is good. Now I'm going to do something that you should not do, and let me explain why I'm going to do that. Well, currently, if I were to play the game, to press the play button, nothing would be added to my array. That is because these objects are already inside the radius, inside the sphere, so it is not going to get updated. So I'm going to get the sphere, set radius, I'm going to set it to 0, and then I'm going to copy once again on the node and set it back to 3000. So you should not do this. I'm also going to comment it. Do not do. Okay. Alright, so this is only so I can show you what it does later. Of course, in a normal level and in a normal game, you would not have this spawned right where you spawn, right? That's not something very good to do. But of course, anyway, this is not very intensive when it comes to performance. You're not wasting anything because it only happens in one frame, but it's useless code. For me right now it's not, but for you it surely is. Okay, now what I'm going to do is to go to edit, project settings, and here we will need to add some inputs. And I already have mine. That is going to be the use rune bound to my button. So let's get use rune. And now what we'll need to do is to create a new boolean. I'm going to call this is using rune. Boolean and a singular variable. Okay, let's get the branch. Now let me explain what this is going to do. By default, this is going to be false, which means that the false pin is going to be executed, which means that we want to set this to true, because now we are going to use the rune. But if this is true, and we press it once again, this means that we want to deactivate the rune, so we are going to set this to false. So we are basically using this as a flip-flow node to alternate between the two values. Okay, now what we'll do is, when we want to use the rune, get metallic objects, and with the for each loop, we are going to get material instance and set vector parameter value. And the value is going to be a pink color, orange, or blue, green, whatever you want, but for me that's going to be pink. So basically what it does is that all the metallic objects in the sphere radius are going to be highlighted with a pink color, right? And then from completed, for now let's hit a set timer by function name. Let's set looping and time 0.03. And let's promote to a variable the return value, and I'm going to call this begin Magnesis timer handle, right? So we're not yet going to set up the function, right? But we are going to have this already in here later, ready for later. Okay, but right now the true part of the branch is not completed. Let's copy this entire code because we'll need it, and we'll do the same thing, but this time instead of highlighting with a pink color, we'll go back to black. So basically we're going to reset the emissive color, and then from completed we're going to get the begin Magnesis timer handle, and we are going to have clear and evaluate timer by handle. Let's compile and now let's see what it does. By pressing E, nothing really happens. Let's see why. So the reason for that not working is very simple. We forgot to set the parameter names. So as I said, emissive is the name. Let's plug it in here. Now, as you can see, it is working just as intended. Now let's set the start building the function called begin Magnesis, which is in the set timer by function name. Add custom event begin Magnesis. Okay, and the first thing that we'll do is a line trace. Of course, from the center of the follow camera, by getting the world location, get a forward vector, multiply this with a float, a really pretty big one from 2500, add the vectors together, so vector plus vector, and then get a line trace by channel. Plug in the start the world location and in the end the add value. Okay, draw debug type for duration and draw time 0.5. Now let's have the return value checked with a branch and also break the out hit. The first thing I will do is to check if the hit actor is a metallic object by casting to metallic object master. And as I said, the metallic object master is also going to be its children. Okay, now the next thing we need to make sure that we do is to see if our metallic objects array contains this return value from the cast, and if that is true, we'll create two new variables. First one called last object, which is going to be a metallic one, so a metallic object master, and the second one is going to be current object, once again metallic object. Okay, and then from true we want to see if the last object is valid. Okay, if it's not valid, then the current object is going to also be the last object, and then we are going to set from the material instance, we are going to set the vector parameter. Set vector parameter value, parameter name is going to be emissive once again, and the value a yellow color, and then the current object is going to be the return value from the cast node. Okay, but if this is true, what we'll do is another is valid. We'll check if the current object is valid, and if that is true, we'll set the last object to be the current object, and after that we'll change the current object to the new return value from the cast node. Okay, make sure this is clear enough, and then what we'll do is to get the last object, we can even copy this. Okay, and we need to make sure that the color is the same pink color that we have in here. Let's copy the hex code and put it in here, the hex sRGB. Okay, and then we can copy the other part of the code for the current object as well. Put this in here, and that should be good enough. Now there's one more thing that we have to do, that is when we don't hit anything and when our cast fails. So let's add some reroute nodes because the same thing is going to happen for both. Okay, one here and one here. Log the cast failed in the second one. Now what we'll do is to check if current object is valid. If it is valid, then we're going to set the emissive parameter to be back to the pink color, so we can copy this part of the code and then replace the last object with the current object. And then we are going to have an empty set for both of them, so they are going to get resetted to their original value, that being null. Okay, let's play and let's see if this works. Going to press E, you can see the line trace, and now if I'm going to hover any one of them, you can see that they are going to turn yellow. If I'm not going to do that anymore, they are going to turn back to purple, pink, or whatever you have, and then I can change to the other one, and so on, so forth. Let's go to the viewport real quick. Let's go to the follow camera and add a spring arm. Let's set the target arm length to 800 and then rotate it 180 degrees on the z-axis, so it faces the same way as our camera, and then add a scene that sits at the end of the spring arm. Okay, and now for both is valid and is not valid, we are going to get the scene, set world location, and the world location is going to be the impact point of the line trace. So let's put the impact point in here and also clean the code a little bit because right now it's pretty messy. Okay. So now that should be it. We are going to use this scene to know where we want our grabbed object to be, right? Where we are going to interpolate that to, and then it is also going to be used when pushing and pulling the object. Currently there are 3 more things left to do: pushing, pulling, and grabbing the object, as I said. So the first one that we'll do is grabbing because the other 2 are related to this one. First thing that we'll do, let's go to add component and add a physics handle. Right, physics handle, you can see it here. Add it and change the interpolation speed to 10. You can even use 15, but I recommend using 10. Okay, compile. And this is not something you can change in the viewport, right? So it doesn't matter. It's not a physical object. Well, it's related to physics, but it's not something you can see, touch, or anything like that. It's just like the character movement. Alright, so first, we will need to create a new custom event. Add custom event, update physics handle. We'll use this to update some information of the physics handle. So for example, we are going to update the target location and rotation. So what we'll do is to set target location and rotation. The new location is going to be the world location of the scene. Right, so get world location. This is going to be used, as I said, to know where we want to grab the object. And for the rotation, we're going to get control rotation. But we are only going to change the z-axis, not the y and x, because we don't want the platform to be able to tilt or go up and down. We only want z. On the z, that means left and right. Okay, and now to update this, we're going to set timer by function name. The function name, let's copy to make sure we get it right. Okay, time 0.02 and looping, compile, and that's it. Now this is going to work. And now we want to see how we are going to grab the object. So, you might not have this input action already created, but in most of the templates you should already have it. For me that is going to be called fire bound to the left mouse button. So let's get here fire, and we'll get for both pressed and released 2 branches. And both are going to check if we are using runes. So if you are using the rune, then we are going to grab the object on pressed, and if we are still using the rune and on released, we are going to release the object. So, before doing this, let's go a little bit to the begin Magnesis timer handle when we clear and invalidate it. Let's get the physics handle and get grabbed component. And let's see if this is valid. And if it's not valid, actually if it's valid, what we'll do is to release component. Now let me explain what this does. So imagine, for example, that we grab an object from the ground, right? So let's say we grab this platform and then we press E once again to disable the rune. If we do that, we also want to drop the component because we are not using the rune anymore. Which means that this is going to be false, so it's not going to do anything. Or at least not for me. Okay, if we are going to press fire and we are using rune, we want to check if the current object is valid. If it's valid, then we are going to get the physics handle and grab component or location with rotation. The component is going to be the static mesh of the current object, right? Because we have to grab a component, not an object, not the entire actor. The location is going to be the world location of the scene. Okay. And then for the rotation, that is going to be the same thing as the update physics handle. Okay, split the struct pin, and that should be it. Okay, now we also have the begin magnesis timer handle, which we should pause. We don't want, it would be really useless to run this code every 0.03 seconds while we don't need it, because we already have grabbed an item, which means that it's completely useless. Then for the other part, what we need to make sure we do is to get the current object, once again is valid, and if it's valid, we are going to get the physics handle and release component. And that should be pretty much everything for grabbing it. Let's check if it's working or not. One more thing that we have to do actually here is that we need to set the spring arm, set target arm length back to 800. But this is only going to be necessary once we create the pull and push functionality. So let's check if it's working or not. I'm going to press E, going to select it, I'm going to press left click, and now you can see how we dragged it. There are currently some errors, so let's see how we are going to fix those. So there are currently multiple errors we need to fix. First of them, which is gonna fix it basically entirely, is that we need to disable do collision test from the spring arm. Then the second problem is that we don't need to get the scene here, we need to also access the static mesh for the world location and the world rotation. And then one last thing that isn't necessarily an error, but we forgot to do, is to unpause the timer handle. Right, so we unpause it, and now we can do everything as intended, select it, and start moving it. You can see it moving only on the Z-axis, not X or Y. And it's also going to move smoothly because of the physics handle, and it is going to react to walls. So everything is working as intended, as I said. Now, two more things, pushing and pulling. Let's see how we do those. First of all, let's go to Edit, Project Settings, Input, and create a new action mapping. This one is going to be called pull/push. I'm going to bind this to button 1, the number 1, and another one on the button 2. But of course you can choose other buttons as well, maybe some mouse buttons, those would be pretty cool. So pull, push, and let's see how we set this up. Okay, so what we're gonna do is to go to key, get name, and then we're going to put this to be a string, so to string. And now we can get here a switch on string. From pressed, selection is going to be the name to string and 2 pins. One that is going to be 1 and one that is going to be 2. So basically, when we are going to press 1, this one is going to fire. When we are going to press 2, this one is going to fire. What we'll do is to get a set timer by function name for both. Both are gonna loop, both are going to happen very fast. Okay, and we are going to promote the return value for both. This one is going to be push handle, and the other one is going to be pull handle. Okay. And then we need to create two custom events. This one is going to be push event, and the other one going to be pull event. And let's copy the names and plug them in their respective setTimerBar function name. Then get the pull event, copy it and plug it in the function name, and that should do it. Now what we need to do is to get the spring arm, get target arm length, then set target arm length. And what we'll do for pushing is that we are going to add 5 units to the arm length every time this fires. Okay, now this doesn't look too pretty, but you can also come here and clean it later. And then we can copy this entirely, plug this in here, move it downwards a little bit, and instead of adding, we are going to subtract 5. Okay, put this in here, and then from released, what we are going to do is to clear and invalidate timer by handle for both of them. Clear and invalidate timer by handle, put this in here, play, and now this should work fine. Okay, going to press 1, you can see it being pushed, going to press 2, you can see it being pulled, but currently it's pretty slow, so let's make this even faster. Let's see, it should be 5 times faster. Okay, so now you can currently see it, everything is working fine, it is going to react to physics, and now we can do all sorts of things with it. You can always pick another one, and now we can do, as you saw in the beginning, the doors that are going to react to this as well because they are metallic. You can do bridges over to islands or whatever there is. There's a lot of things you can do if you're creative enough for it. Thanks a lot for watching until here, I really appreciate it. Let me know down below if you have any other questions regarding the tutorial and I'll make sure to answer them. If you want to see more videos in the future like this one, consider subscribing to stay up to date with everything. Big shout out to Xeon, Donald Anderson, Kama Sutra Industries, Andrew Millspog, Nino, Daniel Moore, Diego Balarezzo, Bruno Gomez, Gilly, Stefan, Badr Al-Kahtani and Roduk for all the awesome support through Patreon. Once again, the project files from this tutorial will be public on GitHub and you can get them from the description below. Thanks a lot for watching and I'll catch you in the next one.